Hi everyone, welcome back to the episode. I'm Gordon. Today I have Orphée here with us all the way from Toulouse, I think.
Yeah, exactly.
So, can you tell us a little bit about yourself?
Yes, so I'm a data scientist at CNES, so the French Space Agency. So I'm working as an expert of machine learning for the various topics that can go from ultrasonography, autonomous ultrasonography to large language models. And I also work for the Ariel Data mission as data scientist. And my main objective in the IDC is to work on the baseline solutions or the machine learning techniques. So I work with Virginie and Angèle, that I think we will see in the video.
So I'm sure you're one of the first person to sort of look at the data set and analyze the data set. Yeah. So what kind of inside lessons have you learned from that?
Yeah. So initially I went for the deep learning problem. So using big models with big convolution to say, this will work, this will answer the subject. But once you look at the data, you see that this is maybe not the best way to actually achieve the problem, because there is a lot of data, and for each of the item in the data set, you have a lot of images. And if you go through them, all the images are quite alike, one from another. So you actually don't see where the planet is actually. So you have to think, what kind of transformation can I make to have something that is useful for the data model, for the machine learning model, sorry. There is a lot of transformation. So speaking with Virginie and Angèle, we come up with a lot of transformation. There's actually the light curve that we can use that make you see where the planet is actually in the transit. So that's fine. So that's a part of the solution maybe. But yeah, so there is a lot of things to consider when you're using this ADC 2024 data.
Yeah, I mean it's quite comforting, if you see a transit, then you sort of go, that there's a planet.
Yeah.
But then I guess when you're looking at the raw images,
you're not sure what you're actually seeing. So this is an image, and the next one is also an image, and the 100th one is also an image that is quite alike. So, what can I do to actually get the right data at the end? It's not easy.
Well, thank you for sharing your insight. Well, let's zoom out a little bit, and I understand that from your background, you're coming out from from machine learning background, and then looking at this mission, from a completely new angle. It's sort of like completely different from the people that we've interviewed before, because coming out from machine learning. So what sort of lessons have you learned coming out of that?
So I think there's this saying that God is in the detail, and I think for Ariel, I come up with good atmospheric characterization is in the detail. The only way you can actually get the proper atmospheric characterization at the end of the whole pipeline of Ariel is by having those details come up to the first scene. So you have to think, as the previous answer, how can you actually do transformation to get the data at the end? And it was really interesting for me because it's a pure data science problem. So I'm a data scientist, so it was totally for me to take this. But since I'm not an astrophysicist, there's a lot of things to understand, to learn. But at the end, I think with Virginie and Angèle, we are coming with strong solutions. So that's cool.
Well, we're coming to the end of the episode now. Thank you so much for sharing with us with all this and insight about the data set. I was wondering if you have any sort of last thing that you want to tell to the participants.
Well, I hope you will appreciate the data challenge because we have put a lot of effort in it. But I think there's a lot of things to do with the data challenge, which is crazy, and we are very eager to see what the participants will come with. So enjoy it and make some proposition, and we'll see how it goes.
Thank you very much. That's the end of the episode now. Thank you so much for sharing with me. Thank you. I'll see you in the next episode. See you guys.
Bye-bye.